So now let's watch out for what will happen when there is no STP enabled on the devices. As you can see here, these devices, they don't have STP enabled. So I'll try to ping this PC1 from this PC0. So I'll click on the PC, go to command prompts and type. So watch out for what will happen. You can see, because this PC does not know the MAC address of this device, it will generate two packets, ICMP and app packet, and it will send out the app packet first. So let's see, it has sent it to switch 1 to forward it. Switch 1 is looking at its MAC address table right now, and it will see that, oh, I don't know where this device is going to. It will just flood it out of all the other ports that are connected to it, except the ports it's coming from. Now you can see that the other devices, they don't have spanning tree enabled also. So what do? They just flood out the frames also, and it just keep looping around, and before you know, the network will start melting down. The bandwidth, it will reduce the bandwidth, and yeah, basically the network might shut down because CPU to start reducing the CPU will be overloading. So now what am I going to do to stop this? I'll go to real-time mode, and I'll go and configure, set up STP on the devices. I'll go and enable STP. So I'll go to on global configuration mode. I'll go and enable the STP back. As you can see, STP is coming up, it's doing the calculation. So I will enable it on all my devices. I will enable spanning tree on all my devices, so the election can go on, and the algorithm can, by the time they are done with the election, they will decide, oh, which one have the lowest MAC address. The one that have the lowest MAC address will now become the boss, right? So that the network can be controlled, can be in control. So I'll need to forward this because it will take 30 seconds. So spanning tree has been enabled and this port has been unblocking. So now let's look for which of the switch is the master switch. So I use the command show spanning tree to check. So this is not the master switch, alright. So let's look for the master switch. Show spanning tree. So this also is not the master switch. Enable show spanning tree. So yeah, you can see that this bridge is the root. That means this switch 3 is the master switch. So every other switch we have to report to it, and all the ports are on forwarding mode. So this is the master switch. So what I want to do now is I want to go and manipulate the other switch, like if I want this switch 1 or switch 2 to become the root bridge, I'll go and configure it. But before we move forward, I want to explain this output to you. So this spanning tree enable means that spanning tree has been enabled on this device, and the root ID is the root details of the root bridge. Alright, priority is 32,769, and the address is the MAC address of this root bridge, and this information means that we are on the root bridge. So if we are not on the root bridge, you will not see this information here, this output. Then the hello time is 2 seconds. That is what I explained before. The hello time is every 2 seconds. All the switches keep sending BPDU messages to ensure that, oh, all the links are up. If they don't receive any response, BPDU messages from any of the link in the maximum H time, that is 20 seconds, the algorithm will have to recalculate that, oh, maybe one link is down. So it will not switch over for redundancy, and end users will not even know what is happening. That is why this port is unblocking, and it's just there for standby. It's not like it's totally blocked. It's just an alternate port for redundancy when extra link or device go bad. So now let's say if I cut this link off, you see that STP you have to recalculate and put this on green. Let me show you. You see, if this link go bad, this one will take over. That is why we are doing the redundancy. So I'll put this back on. And you see that STP we have to recalculate again and put this one on blocking. All right, that is the most important part about redundant network. So now I want this switch to be the root bridge. So let's go and configure it. So I'm on global privilege exec mode. So I'll use conft to go to global configuration mode, and I'll use the command spanning tree VLAN 1, then the priority that I want it to be. It have to be the lowest priority, right? So this is the detail of the root bridge. The root bridge priority is 32,769. So I have to reduce it here to 4096. And you see that spanning tree we have to recalculate. It's doing the recalculation. So it will now realize that, oh, this one have the lowest priority. It will now make this the root bridge, and it has put this one on blocking. So this one was our root bridge, right? So let's do the show spanning tree again. Show spanning tree, and you see that this one is no longer the root bridge. This is the root bridge information of the root bridge, 4097, and the MAC address of the root bridge and the port it's connected to. So this is the information of this device we are on right now, and you can see that the priority is higher. So now let's confirm our root bridge. I use end to go to privilege exec mode, and I'll do show spanning tree. So you see that it's stated here that this bridge is the root. Now I want to show you guys one other thing. I want to configure PortFast on this. Okay, I'm supposed to configure. Let me configure PortFast on this root bridge. But before then, let's ping our network again, and you see that it will not flood the frames anymore. Even if it will flood it, even if it doesn't know the MAC address, but STP has blocked that part where it will just be the frame will be looping, you get. So now it will just forward it to the, even if you flood it, now it has flooded, right? But here will be blocked. It will not just, the loop will not just be going around. All right, so PC1 has already sent the reply because it has seen that, oh, this is my MAC address, and it will see that this one is on blocking. So that is the most important thing about STP, to save our network from crashing. So I've enabled PortFast and BPDU Guard on FA03 and FA04 on the master switch. Now, the reason why I'm enabling PortFast is because you don't want end users to wait for the default 30 seconds for this spanning tree to take over, right? It immediately end user connects, the link will just show green, and let me show you what I'm trying to explain here. When you connect this end device here, now for example, this one it has not been configured with PortFast, you see that it will take time and it will take 30 seconds. So you don't want your user to be waiting. So it's important to configure PortFast on the end devices. And for the BPDU guard is to protect the switch from unauthorized switch to connect to our network, right? Our master switch. So I configured BPDU guard on the Fast Internet 04. So you see, it will put this link on red that no, this one is not allowed. You see, it will not turn green, nothing. So that's what I want to show you about STP, and I wish I would have gone in depth more than this, but thank you very much for watching my video and staying with me till this time. Bye.